Hi everyone, welcome back to the worst YouTube channel on earth. Today we're going to be going over volumes of pyramids and cones. So last time we went over the volumes of prisms and cylinders, and those two were very similar to each other. And pyramids and cones are very similar to each other as well, as you'll see from their formulas for their volume. So the volume of a pyramid is 1/3 times the base area times the height, and since a cone is basically a pyramid with a circular base, then you would just replace the base area with the area of a circle, and of course that's what happens. So the volume of a cone is 1/3 times pi squared times height. So before we go on and explain why this is, we have to explain something, and that something is called Cavaliere's principle. So let's explain Cavaliere's principle. Let's say that you have two solids that have the same height, and you draw parallel planes to the bases that are equal distances from the bases, and separate the solid into a bunch of cross-sections, or a bunch of plates, basically. So now I've separated both of the solids into a bunch of plates. And Cavaliere's principle says that if they are the same height, and each of the cross-sections has the same area, then their volumes are equal. And the same applies for shapes like pyramids and cones as well. So let's say that you have two pyramids with the same height, and if you formed a bunch of cross-sections with parallel planes that were equal distances from the bases, if the area of each cross-section was equal to its corresponding cross-section on the other solid, then their volumes would be equal. So let's first explain why the volume of a pyramid is 1/3 times base times height. To do this, I'm going to draw a cube that has side length of s. And I'm going to pick one corner. Here I'll pick the corner on the top right that's closest to me, and I'm going to connect it to each of the faces that don't touch that corner. This is going to form basically a bunch of square pyramids, a bunch of oblique square pyramids, and I'll draw them on the right so that you can see them unconnected, and I'll shade in their bases as well. So as you can see, I'm connecting that corner to each of the three bases that don't touch that corner, and I'm forming three oblique square pyramids. So each of these pyramids have the same height, which is s, and each of their corresponding cross-sectional areas are equal, since each of the lateral edges has the same slope and distance. Then by Cavaliere's principle, then the volumes of each of these three pyramids is equal. So here I'll just draw in all those plates. Each of them have areas that are equal to the corresponding plates on the other pyramids, and you can see that all of the volumes are equal. So if the volume of the cube is base times height, and there's three pyramids inside that are congruent, then each of the pyramids would equal 1/3 base times height. Let's try to explain the volume of a cone. So let's say that we have an octagonal prism with an octagonal pyramid inside of it. Both the pyramid and the prism have a height of h and a base area of b. So we already know that the volume of the pyramid is 1/3 times base times height. So what if we drew a cylinder that had the same height and the same base area as the octagonal prism, and we drew a cone inside of it that had the same base area and the same height as well? So this would mean that by Cavaliere's principle, since each of the cross-sectional areas would be equal, then the volume of the cone would be equal to 1/3 times base times height, and since the base of a cylinder is pi r squared, it would be equal to 1/3 pi r squared times height. Let's do a few practice problems. Let's say that we have an hexagonal pyramid with a base edge of 6 and a lateral edge of 10, and we have to find the volume. So we know that the volume is 1/3 times base times height, so we first have to find the height of the pyramid. And we can do this by forming an equilateral triangle with the central angle and two radii of the hexagon. Then we can form a 30, 60, 90 triangle using the apothem, radius, and 1/2 of the base edge. Then we can use trigonometric ratios to find the length of the apothem. After that, we can find the area of the base by multiplying 1/2 times the apothem times the perimeter. After that, we just multiply the base area by the height of the pyramid, divide it by 1/3, and we get the volume, which is 249.42 cubic units. So now let's do a problem with cones. Let's say that we have a right cone with a radius of 4 and a slant height of 12. So we know that the volume of a cone is 1/3 times pi r squared times height. So first we have to find the height, and we can just do that by using the Pythagorean theorem. And we get that the height is 11.314. Then we can just plug that straight into the equation and get that the volume is 189.56 cubic units. So that was the volume of pyramids and cones. Hope I didn't help.